Okay, hi, we're gonna record this meeting. Ethan has a video. We just videoed a drop, and we're going to use Logger Pro to help you measure the drop, and I'm gonna show how to find acceleration from the video, hopefully. Okay, so I'm going to share my screen with you. Hopefully this works. Oh my gosh, look what's happening here. What a crazy thing that is. That's some sort of hack, I just know it. Okay, let me present my screen. Should I do the entire screen? Probably just entire screen. I'm gonna just present my screen here. So now I'm like one of those crazy things. Okay, so hopefully you're seeing this. This is my Logger Pro, so I just downloaded Logger Pro and opened up the normal thing. So I go to Insert, and I go down to Movie. Okay, now here's where I remember I have the movie on my drive because I took the video on my phone, and I'm gonna show you my drive, which hopefully doesn't mess anything up. And I had a video that I called Ethan Drop. So it's not good enough to have it on my drive, so I need to download it. So I'm going to download it to the computer. And you can see that here coming up. And I'm just going to say show in folder so I can see where it is. And now I have a file right here, and it is in this folder. So now I kind of know where it is. Maybe I'll move it to my desktop. So I've moved that to my desktop, and let's see if I can find it now. So I go back to my Logger Pro. And if I go to desktop, where I hopefully kept it, and I don't see anything under movie files, so I'm going to go to click all files, and then the Ethan Drop is there, but it's just a shortcut. So I don't think that's going to work. Let's see if it does work. Oh, it does work. Okay. You'll notice that this video is sideways, and I took it vertically with my phone. The computer's flipped it. It actually doesn't matter. Okay, and I'll show you why. So let me move this window up here a bit. So two things to keep in mind. You have this slider bar here where you can slide, as long as you keep the button in the gray. If your cursor goes out here, it won't do anything, but once you go back to the gray, it moves it ahead. And so you want to get to a place where your object has already started falling. So I'm going to go to a place where I know it's free of Ethan's hand. I'm going to start right here. These tapes on my cupboard are a good place to drop things because you can read the distances easily. So I'm going to start right there. And now I want to start measuring things with the program. So I need some buttons, and they're always hide them. So right here is where you show the buttons. And there's a few of them up here. And if you hover over them, you'll see what they are. If you want to select one point and do something with it, it's that. If you want to add points, it's this. You're going to set your origin, which we will use, and your set scale. That's the first one we're going to use. So you click on this, and we need to have, I'm going to make this as big as I can so I can see it. We want to, this is 0.2, and up here is 1.2. So I'm just going to do this fairly roughly. And I'm going to go from 1.2 to 0.2. And that's 1 meter. So I click OK. And now the computer knows the distance here. Okay, so it has a reference to everything else. Now, if you want to, you can set your origin so that your beginning point will be 0. So I'm just going to click at the bottom of my blurry image of my object. It doesn't matter if it's blurry. And I click there. And if you want this to be y displacements and velocities, you can turn this so that your origin is like this and your y-axis is the one it's dropping down. It doesn't matter particularly. There's not an inherently right or wrong thing. but let's see if I can get this straight now. And it doesn't have to be perfect, but I'm gonna try for right there. Okay, so I've set my origin, and now I want to start adding points. Actually, I wonder if I should move this. I'm gonna move this over a bit so I can see the object. It's not on the line. So we're all set up now. I set my scale, I set my origin, and now I want to add points. So I click add point. And I'm going to go to the bottom of the object, part that's in the front part of the draw. So I click there, and you'll notice that my object moved. That's because the computer is advancing to the next frame. And so because it knows the time between frames, I can just keep adding points here, and we have a displacement. This is going to be a little bit out of vertical, but that's okay. So I keep going down to the bottom of the blurry object here. And Ethan and I are doing this as a verification. He did this a different way. We just want to make sure that we've got the right stuff here. So that's going to be the last point that I'm going to add. And I'm going to reset my origin now, just so that my motion is a little bit more in line with my y-axis. Okay, and now we're done with our video. It'll stay there. If you think, where's my video? It's just back here. It's still there. It's just a few windows kind of piled on top of each other. Okay, so now we have this nice graph and all this data. I didn't have to enter anything in. It's nice. And we have displacements, and we should have time back here, and we have x displacement, y displacement. We don't care about the x displacement because I twisted my my origin, and you can see here in the y values, it starts really close to 0, and then it gets more and more negative because we're falling vertically. My x velocity, again, I don't care about it because it's going to be really small. That's the sideways velocity. The y velocity is the one that I care about. You'll notice there's no acceleration because the computer cannot calculate that just from measurements of distance and time. But we can see the velocity here, and this is good because we can see this negative velocity. The negative just means downwards, and it's getting more and more negative, so it's getting faster and faster as it drops. Okay, so how much faster? Let's find out. So if we click here, I don't know why it puts both displacements here. We just want the x. So I'm gonna, whoa, sorry, not the x, the y is what we want. So here's our y velocity. Now, does this look curved or linear, do you think, Ethan?
Kind of curved.
Kind of curved, I think so too. If we do linear, let's just try. We go, yeah, it's actually not, this is a straight line just for reference. It might be linear, but I don't think so. I think we'll X that out. And then we'll go up here, we can click on curve fit. And I think this is quadratic. So you can see there's proportional, there's linear, quadratic, and a bunch of other stuff. There's sine functions down here if you scroll down, and all kinds of other relationships that you could try. This is an acceleration, so we're going to try quadratic, which really means a squared relationship. And we're going to click try fit. And that looks really good. So we click OK, and we get that line. You can drag the box around to put it where you want. That looks really nice to me. Lines up perfectly. Okay. And now what we can do is we can say, I would probably cut and paste this graph to put into a lab if I was doing a lab with this, and I might cut and paste my time and y displacement. Okay, and I would put that in my lab. We won't do that right now. I'm going to click here now and do the y velocity, and you'll see this. What do you think about that, Ethan? Straight or curved?
Straight.
Pretty straight, yeah. Right? So if we take our slope here, what is our slope? What do you read there?
Negative 7.9.
Negative 7.9, almost negative 8. So we would expect this number to be negative 9.8. So it's a little bit less. Why do you think it's a little less?
Data is the uncertainty.
For sure, there's uncertainty in data, so we could probably move this around a little bit and make it a little bit steeper. Maybe my last 2 points were a little bit out. And you could do that if you find, oh, the ball did something weird or it hit the ground or something. You can click on a point. Let's see. Click on that point and, uh-oh. No, I did it. I pressed delete and I have no graph anymore. Now what do I do? Let's go Control Z. Hey! Okay, so if you do something, if you erase something, click Control Z, and that's your undo. I should be able to do this. Oh yeah, see down here, there's a little square bracket, and it says click and drag to reset. So I'm going to move it. Oh, if you can try to get over that bracket, and then you can move that to only graph certain points and not other points. So now I'm including this area, but not those last 2 points, which I thought were a little bit off. And maybe I'll keep. Let's try this. Okay, so now I'm up to 8.5, 8.6. You can do that if you want to. But we're fairly close, and I think it's less than 9.8 because we are hitting air resistance, especially at the end. So the acceleration is actually getting lower as the ball falls. If we drop something heavier, like a big weight, there would be less of that, right? But this is pretty acceptable, especially for physics 11. We're close to 9. Okay, now if that's all you need to do for your lab, you're good. You can just use what I've shown you here for video analysis. There's another little tidbit that Ethan and I are interested in, because Ethan's problem was he calculated his data a different way, and he had displacement over time, and he had a line like this. And what we wanted to do was graph y versus t squared. We wanted to square the time instead. And so I'm going to make kind of a deliberate calculated column. So I'm going to click on data, go to new calculated column, and I'm going to call this t squared for short. And I'm going to click in the expression. I'm going to look at the variables, and I want time here. Maybe that's what we did. Anyways, yeah, so the time is my x-axis, and I'm going to do this little hat. You have to do Shift 6 and a 2, and that should square all my time values. So if you go over to the data now, and you have to click on it to highlight it, and you'll see a new column here, t squared. And if you compare that to your time values, let's see if I can scroll over and see. So 0.5 squared is 0.25, and so on and so on and so on. So all of these are time squareds now. So now, without really having to plot anything, I can click here on my time, and I can put in t squared instead of time. And I get a pretty nice straight line. Let's see what the slope is. Interesting. Okay. So the slope of this line is about -3. And the reason that that is kind of legitimate, even though it's way less than 9.8, I'll show you why that is pretty close to being legit. I'll go back to my meeting here. And I'm going to stop sharing my screen. Did I stop it? I think I've stopped it. And so I want to show you on the board here why. you. And it's Ethan and I were talking about this, and he was interested in it. And, you guys are coming up to the place where you're looking at relationships and kind of working with relationships and manipulating them and seeing if you can prove them. And so we were looking at this. Now this is a known relationship, right?
Yeah.
And what did we do with it?
The velocity initial is 0, so therefore
Right. And so because we dropped it from 0, we can say this is and what's next?
Then move the time. Yeah.
So we can divide both sides by t squared. And what we end up with is A. Okay, so that slope of that graph that I showed you, our graph looked something like this. We had distance and time squared for Ethan's drop. And we ended up with a straight line. And the slope of that line was somewhere around 3, I think. The reason it's so low is because the relationship here is that this slope of distance over time squared is half of our acceleration. So I'd say ours is a little bit low, but that's okay. It would suffice it to say that what you should see here is half of your actual acceleration. The uncertainties are magnified in this case because we're squaring the time. So it's kind of like if you have this much, if you have an uncertainty of 4, when you square it, it becomes 16. So our actual, like our measured acceleration was about 8.5 or something, 8. And so when you get half of that, it's even less than half of the real acceleration. But that's okay. And in physics 11, this is totally fine. So you can do what I just did in a few minutes and manipulate a relationship and find things out, and you can do that with LogRepro using the techniques I just showed you. I'm going to stop recording this now. Maybe. I love you.